Okay, next up is part 3 of question 10. Here we're looking at the surface described by the equation z is equal to 4 minus the quantity x squared plus y squared. This is what's known as a circular paraboloid. All right, and so just like the first two, okay, we'll start out by looking at the yz traces. So set x equal to c, you get the equation z is equal to 4 minus c squared minus y squared. So that's a family of parabolas, all opening down because of the negative in front of y squared. If you look at the xz traces, well, it's essentially the same family, right? But just looking now, right, at the intersection of our surface with planes parallel to the xz plane, but we get the equation z is equal to 4 minus c squared minus x squared. All right, now for part C, looking at the xy traces, we set z equal to the constant c. So I get the equation x squared plus y squared is equal to 4 minus c. Now on the left-hand side, right, we have the sum of two squared terms, right? So this is non-negative. So the right-hand side has to be non-negative. So that implies that c is less than or equal to 4. And this, right, describes what? Well, it describes a circle centered at the origin of radius root 4 minus c. Now in the special case when c is equal to 4, this right-hand side is 0. And that happens only when both x and y are 0, so in other words at the origin. And now as we let c decrease, right, from 4, okay, the right-hand side will get larger, meaning the radius of our circle will get larger, okay? All right, so now let's put that all together. So if I cut my surface with planes parallel to the YZ plane, I'm going to get a bunch of parabolas. So if I cut like this, you should see a bunch of parabolas. If I cut parallel to the XZ plane, again, I should see a bunch of parabolas. And then cutting parallel to the XY plane, I'm seeing a bunch of circles. So circular cross sections. So you put these all together and we're going to get this, well, circular paraboloid. Okay, and just like we saw for the first surface, that's a good name, right? There that we call that an elliptic paraboloid because the cross sections parallel to the XY plane were ellipses. Here there's circles, hence the name circular paraboloid. But in any event, that does it. All right, thanks.